Okay, here we go. All right, so we're going to talk about chapter 5, which is least squares regression. Okay. All right, so we're going to talk about OLS regression. OLS stands for ordinary least squares. Okay? And what it is, so OLS regression, the regression line is a straight line. We're only dealing with straight lines. Obviously, you can have non-straight lines, but on our class, we're only going to deal with straight lines. Straight line that describes how the response variable y changes as explanatory variable x changes. So we're talking about OLS regression. The only kind of regression we're going to do in our class. There are other types, but it's the only type that we're going to be concerned about. Okay? All right, so the idea here is, let me just kind of give you an example. You've drawn your scatter plot, let's say, and it looks something like this. Okay? So you're going to say that looks like roughly a straight line, correct? Okay? Now there are lots of different lines I could draw here that might have a slightly different slope. Okay? The idea behind OLS regression is it minimizes the vertical distance. Okay? So the idea here is, if you take a point here, we're going to minimize all of these vertical distances here. Okay? Now, there are other ways to minimize it. We could minimize the horizontal distance. Okay? Or we could minimize what they call the orthogonal distance, which would mean orthogonal means it's a right angle, so you just make right angles with all of these. Okay? And what I'm telling you is OLS, it minimizes the vertical distance, and that's the best method. Okay? And I'm just going to say, trust me on that, because if I showed you a proof, you'd be like, okay? So OLS regression, that's what we're doing. It minimizes the vertical distance. Okay?
What do you mean by minimizing? Are you bringing them in or what?
Well, so there's different ways. So as I just said, there's different ways to measure each point to the line, and we're minimizing the vertical distance.
Minimizing, does that mean measure? Like you take the smallest one, or are you actually taking it?
If we have time at the end of the class, I'll answer that question.
Okay.
But just trust me that this is the best method, okay? And I'll show it to you at the end of the class, and you'll be like, I wish I'd have never asked that question.
All right.
Okay? So I'm just going to say trust me for that. Okay? Now, the equation, how do you find the OLS equation? Okay? And there's a couple of formulas. I will have these on your formula sheet. But you're familiar with the equation y equals mx plus b, right?
Oh, yeah, let's go.
Okay, you guys remember that. You use that all in Math 1010. And have you ever wondered how they came up with those equations? No, you haven't wondered, right? But you should. Okay? So the idea here is your slope, m, equals r, your correlation coefficient, r, times s sub y over s sub x. So that's how they find the slope. Okay? And your b, your y-intercept, is y bar minus your slope that you just found, m times x bar. Okay, so those are your two equations that you're going to need to know for this section. Okay? So let's go ahead, and I'm going to open up, go ahead and open up Canvas. Hopefully I have this up here, and if not, I'll put it up there shortly. M times X bar, right. Okay, so let me see if I've got this spreadsheet up here. Well, that takes a long time to warm up. I do, okay. So go to Canvas, go to in-class worksheets, and then, here, let me show you this. Let me start sharing. Okay, if you go to Canvas, open up worksheet 4.1 here. I'm going to turn this so I can see a little better. Okay. So let's just use this as an example. Okay? What sheet is that? It's worksheet 4.1. Okay? So let me ask you first the question. A golfer is chosen to swing a ball on a 70-degree day with no wind. Okay? So you want to see if there is a relationship between your club head speed, how fast you swing your club, and the distance the ball goes. Do you think that there might be a relationship between how fast you swing and how far the ball goes?
Yes.
Okay, that seems reasonable. Okay, so the first thing we want to do is we want to create a scatter plot. And oh, by the way, only one person watched my video. It was too easy. We all learned it so well you didn't need to watch it again? Okay. So how about Tanner? Can you tell me how to make a scatter plot?
Just like highlight all the data.
Highlight the data here.
Then you go to
Insert.
And go over to the dotted
Scatter plot, okay. All right, so let's finish our thing. We need to label this properly. How do I label it? Click on the plus sign. Axis titles. What do I put down here? Club head speed. And by the way, I probably didn't tell you, but this is in miles per hour. And this is what is this, Ashley?
The distance.
Distance. Oop, I can't spell. Distance in yards. Okay. And what should I put for a title here? "70-degree day, no wind." Okay. All right. So now it looks like, so does linear regression seem like a pretty good idea on this?
Yeah.
It seems like it. Okay. So if we have time, we'll do the calculation. We'll do the correlation coefficient. But do you guys remember the cheater method? You can't use this on the test, but yeah, it's coral. And then what do I do?
Highlight your data.
Highlight just your data like this. Is that right? Nope, that's not right.
No, you only do one.
You only do the first column, X, comma, and then your Y. Okay, so we see this. Oh, I forgot a comma. That's weird. So I got 0.938. So that seems like strong, moderate, weak, or no correlation. Very strong. Okay. All right. So now we want to find the equation of this. Oh, well, let's see. If I right click, well, no, I don't want to do that yet. We want to find the equation of a line that would fit those points the best. Okay? So how would we do that? We need to find the slope. M equals what? Okay, we need to find, so we're going to need to find the mean and the standard deviation, right? You should always just plan to find that on every data set. Okay? So the mean is what, Nicole? What's the command for the mean?
Oh, you can do the average.
Average. And then you curse Bill Gates for using the wrong word, right? Okay. Okay, the mean is 101 yards, no, 101 miles per hour, and it's 266 yards. And you remember the standard deviation, Brenda? STDEV of both of those. 7.74 yards and 2.29 miles per hour. Okay? All right, so my slope is what gauge? How do I find my slope? What's the formula for the slope? Okay, what's R in this case? You don't know? What does R stand for? Correlation coefficient. Where did I find that?
Okay, so the 0.93.
938. Okay, times. What's S sub Y? What's S sub Y? Gage thinks he's off the hook, but he's not.
Well, I mean, if anyone would be willing to help.
Oh, you don't know what S sub Y stands for? Standard deviation of Y. What's the standard deviation of Y? Do you see that 7.74? Right here?
Oh, okay. And then so they would just divide that by the other one, so then it'd be 2 points.
Divided by 2.295. Okay, so we're saying the slope is 3.1661. Okay? Now, how do we find the Y-intercept? It must be Lindsay's turn.
You'll do the mean of the distance.
Okay, the mean of the distance, which is 266.75 minus parenthesis slope that we just found, 3.16. Okay.
Times by the mean of speed, which is 101.8.
101.875. Okay. Okay, so I found my slope and my Y-intercept, and so therefore, Landon, what's the equation? Y equals what? 1 x plus minus 5.7966. Okay. Now, do you think there's a way to check your answer? Yes. How many points do you get for checking your answer? 0, but you'll at least know you're right or wrong, right? Okay, so here's how you're going to check your answer. Okay, so I'm going to pick a point. Any point will do. It doesn't matter which one you pick. And then you're going to add a trend line. And look, it puts that dotted line in there for you. Some of you think that on the last test. Then you're going to add the equation. And you can also display the R squared on there. That's kind of cool, right? So as we look at here, look at that. That's the exact same equation I got. You guys are as smart as a computer, again.
I missed the B. So what do you times that by?
Okay, I'm going to do this really quick. Right click, add trend line. You're going to go to the bottom here. You're going to display the equation and the R squared. Okay? So we good there. Now, you missed the equation on the B.
Yeah, so it's your mean minus your,
Which mean? You got two means, right?
so it's the speed, the x speed minus the,
So it's the 266 minus,
what's the 266 minus, okay. Hold on, so it's 266 squared. Okay, 266 minus, isn't it minus your 101?
nope. What's your M?
Okay, so
Your slope that we just found, so it's 3.1661 times,
The square of that.
Oh, yeah, okay.
So that means times by 101.
Or you
Okay.
can square this.
and your X bar is
Okay, I got it.
101.
And then the y, you find out the y?
The Y is just the Y. This is your Y equals mx plus B. So you take your slope here, M, and you take your B, and you just plug it in your equation.
So you take the slope.
Okay, you remember the equation Y equals mx plus B right here?
Okay.
You learned back in Math 1010 or high school or wherever you learned it? Okay? Does that make sense?
Yeah.
Okay, and you're just plugging these numbers into the equation. Okay?
Sorry, how did you get the stats in the top right?
Yeah.
Okay?
Sorry about that.
So I picked a point, any point will do. Actually, somebody else tell me, because you've seen it 3 times now. This will be the third time. Right-click a point,
Let's say
add trend line,
Go down.
go to the bottom,
Say, split equation.
split the equation and the R squared. And then you can move it around. Look, I've got it on there 3 times now. You only need it on there once. Okay? Does that make sense? Okay. All right, so here's a couple things I just want to emphasize really quickly here. We might actually have time to answer that question that you guys are going to scream at, run away from the room screaming. How do I turn this off? Stop sharing. Okay. All right, so some things to remember about regression. So it can be used for prediction. Okay. So for example, you could predict how far a ball would go at 104 miles per hour swing. Okay, and we'll do that in just a minute. Except for 2, I want to say that prediction outside the range is risky. Okay.
What does that say after, is that football?
Predict how far the ball will go at 104 miles per hour. Okay. Number 3, watch for outliers. They can affect the Ols regression line. Okay, so you want to be careful about those. All right, another thing, let me go over here. It's probably good that I only use half this board because you can't see below there anyway, right? All right, So let's talk about the question of causation. Okay? Number one, a strong relationship does not mean a change in one variable causes change in the other variable. And you remember last time we talked about polio and ice cream? Okay, does ice cream cause polio? No. If you outlawed ice cream, all of a sudden they wouldn't have stopped the polio cases, right? Okay? So remember, correlation, this is another way to say correlation does not mean causality. Okay? And the reason why is because the relationship between two variables could be caused by lurking variables. What was the lurking variable in the polio case? Swimming. Or really a virus in the swimming pool, or the lake, more likely a lake than a swimming pool. Hopefully the chlorine kills the polio virus. Okay? Number three, the best evidence comes from randomized experiments. Okay. Number four, the observed relationship could be due to A, direct cause, B, common response, or C, confounding. Remember we talked about cigarette smoking and, we talked about sugar causing heart disease, right? But it was really smoking that caused it. It was a lurking variable of smoking. Okay?
So it says direct cause and then what?
Direct cause, a common response, or confounding. Okay? But here's the interesting thing. Oh, that's off the board, barely. Number five. Let me just throw this out here really quick. 5, that observed relationship can be used for prediction even if not the cause. Okay? All right. You should sit over here, Brady. You could see both the computer and the
Yeah. I just have
That's why I say you should sit over here. All right. So let's go back to this example here. I wanted to see how far the ball goes with a 104 mile per hour swing. Let's go back to our spreadsheet for a minute. Okay. So notice here we don't have a 104 mile an hour swing. Okay. Now, let's say that, so we can use this equation right here, and I want you to use the equation to predict 104 mile per hour swing. Okay? So Colin, how would you do such a thing?
Sorry, I wasn't listening. I'm still writing down notes. One more time.
Okay? I want you to use this equation here that we just found to predict how far the ball would go if you swung it at 104 miles an hour?
Would you just plug in the 104 into the X?
104 times what?
M.
Which is right here.
And then plus.
You'd add your B.
Yes.
Okay? So we would predict in this case that if we swung the ball 104 miles an hour, it would go 273.478 yards. Okay? So as we look at this, yeah, that's right, almost 274 yards right there. Okay, 273.5 yards. That's where the line says. Now, an interesting thing here, you know, twice we swung it at 100 miles an hour. And one time it went 257 yards. And the other time it went 263 yards right here. So we would have predicted it would probably have gone about 261 yards. Okay? So this area right here, the difference here, this vertical distance, that's what we call our residual. So the residual is the difference between the predicted and the actual.
I like it when you type it
Better than my handwriting? Okay. All right. So, and in fact, if we predicted this, okay. So how about, who haven't I picked on? Braden. Tell me how far, if it went 100 miles an hour, how far would the line have predicted it? We're just going to use the same equation that Colin just used. You're writing notes you didn't get. Okay. So, can you plug 100 into this equation right here? So I'm going to take my 3.1661. I'm going to multiply it by what? By 100. I'll just click on that so I don't have to type it. And then we're going to add what? Y-intercept, which is negative 55.7966. So we would have predicted that it would have gone almost 261 yards. So the residual, this is off about 3 yards. Do you see that? And if I take this, this computer sucks. Well, so this one here, I'm just going to compare it this way. I don't know why it doesn't let me see what I'm typing. It's really super annoying. Here, we'll do it this way. So this one was off by a little more than 2 yards. Okay? Now, would you like me to answer that question for you about why the vertical distance is the best distance?
Wait, that's not, I think the question is,
Yeah,
we don't
that was
really-
not our question. The question was, what did it mean to minimize?
Okay, that's what I just said. So let me show you what it means, okay? This is beyond the scope of this class, but here's what I mean. Do you see here, in fact, I'm going to move this out of the way, okay? So we've got the prediction here. So here's what I'm going to do. I'm going to F4 that, and I'm going to F4 that. Now, you don't need to take notes. In fact, I'm not going to test you on this, but I am going to try to answer your question, okay? Now, so I could predict, I'm going to use that line. Oh, I did something wrong. Okay, 20. Oh, I know what happened. My formula's messed up. So we're taking this number, and we're going to multiply it by that number. That's what I wanted to F for. Okay, try that again. Okay, so we can talk about the residual here, right? This is the actual minus the predicted. So you can see here, this is off by almost 4 yards. Okay, I'm going to copy this down. And you can see that these are all, you can see how these differences are, right? Okay.
You really did the.
I did 260 minus 2, or 257 minus 260 is negative 3.8. 264 minus 267 is negative 3.14. Okay. Now you can see some of these are positives and some of these are negatives. Okay. I don't want them to cancel each other out. So one of the things I'm going to do is I'm going to do the residual squared. Okay. And what I'm going to do is I want you guys not to take notes. I just want you to pay attention so that you can get an idea here.
Okay.
Okay.
You don't care about this right now?
You don't really care about this, but I want to explain this to you. Okay. So I'm going to take this number here and I'm going to raise it to the second power. Okay. This is answering your question. More than you ever wanted to know. Okay. If I add these up, this is called the sum of residuals squared. Now, just so you know, I make my Math 2040 students do this. Okay. So what I'm telling you is that the ordinary least squares method, which uses these two formulas here, this is the best method. It minimizes all of these distances. It uses calculus to do that. Okay. And now you're like, oh man, I don't want to learn the calculus. Well, here's what I want to do. You guys also remember from Math 1010 or from high school, look at these 2 points here. I've got this point here and this point here. They look like they're on the line, right? So this is point 99,258. I'll put that in orange. And this is point 105 and 277. Okay? Do you see that this point here and this point here are basically on the same line? Okay? Now, you guys remember that before today, you remembered how to find the equation of 2 points. Remember how to do that? You remember that your slope equation was y2 minus y1 over x2 minus x1, right? Remember that equation? Okay. So here's what I'm going to do. This is the old Math 1010 method. So I'm going to find the slope between those two. So y2 minus y1 divided by x2 minus x1. So this gives me a slightly different slope. 19 divided by 6 is 3.166. So you can see these two numbers here are very similar, right? Now, you may say, you know what, I don't trust your method. I like my old method better because I understand it better, right? Some of you thinking that? No. Okay. So if I've got a slope and I've got 2 points, can I find the line? You guys remember the equation to find that line? It's called the point. Whoops, don't write that. It's called the point slope line. Remember that one? No? It should be familiar. You had it in Math 1010. Remember the name. Y minus y1 equals m times x minus x1. Does that sound familiar to you now? Ashley's like, no. You did take Math 1010, right? Okay, well, it should be familiar. Okay? So here's what we're going to do. We're going to pick one of these points. Okay? Do you want to pick the one I highlighted there? Is that a good one? So I could say that y minus 277 equals 3.166667 times x minus 105. Do you remember doing that, Lindsay? Vaguely. Okay. Here's what I'm going to do. I'm going to add 277 to both sides, so that this becomes y equals 3.166667 times x minus 105 plus 277. Okay? So this is a slightly different, well, it's actually really different. This equation is very different from the one we just found right here. Do you agree?
Yeah.
Okay. So the question is, well, maybe this line is a better line, right? How do we know? So here's what we're going to do. We're going to do the same thing. We're going to do the prediction. We're going to do the prediction. Okay, yeah, but you're going to see, yeah. Okay, so we're going to do the prediction, okay? So here's what we're going to do. We're going to take our new slope. We're going to multiply it by the number x minus 105. And we're going to add 277. Okay? So this is our new equation. So the first time we predicted it would go 260.8 yards, right? This time we predicted it will go 261.1. So we think it'll go farther. Does that make sense? Okay? Now what we're going to do is, yeah, we're going to find the residual. So in this case, I'm going to F for that. That's all I need. Okay? We're going to copy this down. Okay? Now we're going to find the residual. So we're going to take the actual 257 minus 261. Okay? So in this case, we were off 3.8 yards, now we're off 4.17 yards. We're off by more yards, right? So it's a worse line. But however, look at this. When I copied this down, oh, look at this. It nailed it. It was off 0 here. So in some cases it's worse. In some cases it's better. How do you know which one's better, right? Okay, so here's what we're going to do. We got positives and negatives again, right? So we're going to do the square, residuals squared. Okay? We're going to take this number and we're going to raise it to the second power. Okay? We're going to copy that down. Okay? So when we did this the first time, we got 49.857. Okay? If this is a better method, it will be a smaller number than that. If it's a worse method, it's going to be a bigger number. Okay? So we add this up. We're adding up all the squares of our residuals. Is that better or worse? It's worse. Okay? So what I'm telling you is that no matter what other method you pick, I just picked another one that I thought you would be familiar with, but you weren't. My way is the best method. There is not a better method.
So you did answer my question in the fact that to minimize, that was my question. To minimize means that you're going to find the slope that's going to get you closest to the actual.
Okay, so let me explain it this way.
Your residuals. That's a good.
I've got a bunch of points here, right? I'm going to draw a line here. There are lots of different lines I could draw. I could draw this line. I could draw this line. Right? Which one's the best line?
Probably the red.
The red one, because the red one is the OLS method.
Yes, it's going to have.
Because these distances here are going to be shorter than, because you'll, so notice here with the red line, I've got a longer distance here, the green line, and I've got a shorter distance here. But can you see that that green line, this green line and that green are much longer than the two red ones that I just did? Okay? So that's what I mean by minimizing the distance. Okay? So, does that help? Is that more information than you ever wanted to know? All right. So, let me just do a couple more examples here. Okay, let's say, for example, oh, I thought I had one here. I'm going to erase this now. Where'd my eraser go? Here it is. Let's say that the OLS equation is to predict the femur from the humerus is humerus equals negative 3.66 x plus 1.1197. Okay? Do you think that's funny?
I think it's pretty good.
It's pretty humorous, isn't it? Okay, so let's say that I want to predict see, I'm going to show you on camera. You may not think that's funny, but I find it humorous. Okay. Predict the length of a humerus if the femur is 50 centimeters long. That was a good dad joke, wasn't it?
Yeah.
All right, so how would you do such a thing? Who haven't I picked on? I have not picked on Audrey.
You're correct.
Okay. Can you help me figure this out?
Yeah. Are we like doing the equation?
Mm-hmm.
So you're doing humerus equals negative 3.66 50
Times 50.
Plus 1.197, is that what that is?
That's correct. Okay. And so when you plug that in your calculator, I'm going to use my famous Excel calculator.
Yeah.
Anyway, equals negative 3.66 times 50 plus 1.197. That is something's wrong. It's negative. Oh, I typed something wrong. Oh, I know what I did. This is the wrong equation. The x is supposed to be on this one. Okay, let's do that again. Times 50. Okay. That's still negative. Times 50. So that would be 50. So your humerus would be 56.19 centimeters long. Okay? Now the question is, what if the humerus is 70 centimeters? How long is the femur? How would you do that when Shire? I haven't picked on you today. Can you see what I wrote there? Oh, it's right there. Here, we'll come back over here. So tell me what to do.
70 equals 1.97 times by x minus 3.
70 equals 1.197 times x minus 3.66. Okay. And what do I put in here for x? Oh, we don't know. So we can solve for x, right? So then how do I solve for x? Add 3.66 to both sides. So 73.66 equals 1.197x. Divide by 1.197. So 73.66 divided by 1.197. Equals 61.54. centimeters. Okay? Okay. So, I think I'm done. We're done like 5 minutes early. How'd that happen?
That was awesome.
Okay, even with your long question.
That long answer.
Okay, so quiz on Tuesday will be on chapter 5. I'll try to figure out if we're going to meet in here or the other room. I think we're running out of stuff. You want to just meet here from now on? Well, it all depends on whether I can get the room, and I won't know until Tuesday.
It's been open like every time.
There's, like, every
No,
time.
last time there was a class in here at 11. Yeah.
Oh, really?
I always check, like, if there's a class scheduled for this time, and there's always a room open. There's always at least.
I hope you're right.
He is.
Okay, so we'll plan on here and just check one of these 3 rooms here. We'll just plan. Do you guys want to just plan on that from now on?
Yeah.
And I'll try to warn you if it's not available. Okay? All right, so see you all on Tuesday.
Yeah, I don't.
Yeah, that one's hard to see.
What was the one?